So when an ellipse is in standard form, it's easy to tell like the major important features of the graph. Okay, because A tells you the horizontal radius from the center, and then B tells you the radius going vertically. Oops, B. So this is what we want. We don't have that right now, right? So we got to somehow rearrange this so that x is factored and y is factored, which means we're going to want to complete the square like we've probably done before. Okay. Let me see what would be easiest. Let's collect the x terms and the y terms first. Let's see. So let's try completing the square for x first. Okay, which means we'll balance this equation by dividing everything by 9. So we got x squared plus 9 fifths into 72. 8 times. I should know that a little quicker probably. We got 16y squared over 9. Nothing we can really do there. Excuse me. We got 64 over 9y plus 64 over 9 equals 0. And so to complete this square, the quick trick I use is you take the terms to the first power, cut it in half, and then square it. Right? So what's missing here? 8 divided by 2 gives you 4. 4 squared. We need to add 16 to both sides of this equation. Okay, so when you do that, you get x squared plus 8x plus 16, and then all this other stuff is still the same. Oh, I didn't paste nicely, did it? What did I do? I made a horrible mistake. There we go. Okay, we added 16 to the other side of the equation over here, so we got to keep it balanced. And we'll do the same thing for the y term. First, though, actually, we should finish factoring this. So if you factor this, x squared plus 8x plus 16, you get x plus 4 times another x plus 4. Right, so we've completed that mission. Okay, so now we got to focus on the y's. Let's do the same thing. Let's get rid of 16y squared over 9. Let's multiply everything in our equation by 9 over 16. Okay? Just copy that down so I don't skip over anything. Nothing's changing there so far. Okay, so in this step, now that we've taken care of x, let's focus on the y terms. Let's multiply everything by 9 over 16, the reciprocal. That way we just have a y term by itself, okay? So we're going to get a 9 over 16 attached here, and that's okay. We'll check that out at the end. Oh, I ran out of room. It's going to look weird for a second. I'll erase it and clean it up, though. Shoot. You ever see those big instruction boards at the top of a lecture hall where they pull down another board? This might be one of those situations where you got to do that. All right, now we got that cleaned up. These are just from the other part. We're multiplying everything by 9 over 16. That way we can just have a y term by itself. So we're going to have 9x plus 4 squared over 16 here. And now 9 over 16 times 16 over 9, that just gives us y squared. And the 9's are going to cancel out, so we got 64. Oh, wait. 9 over 16 times 64 over 9, 16, 32. That gives us just 4y, so that's nice. And then we're going to have, wait, that gives us just 4 here. And it gives us 9 over here. So when you multiply this 9 over 16 times these, They're going to cancel out nicely because the whole thing is supposed to make an ellipse in the end. Now we can factor. Factor the y terms, okay? So that's going to be something times 4 that adds up to negative 4. That's y minus 2 and y minus 2. So if you factor that, you get y minus 2 squared, just like we're supposed to. And then we said we're trying to, when we're trying to go for that standard form of an ellipse, there's not supposed to be a coefficient up here. It's just supposed to be numbers on bottom. So we got to take care of this 9, which means we're multiplying everything by 1/9 the equation. Okay, so you get x plus 4 squared over, unfortunately we got to do 9 times 16. It's 144, so in other words, 12 squared. We got y minus 2 squared over 9 equals 1. There, we finally got it. That's the standard form of the equation of an ellipse. Let's see which one we got to pick here. Oh, just at the graph. Okay, so it's centered at negative 4, comma 2. Negative 4, comma 2, that could be a winner. Negative 4, comma 2, that's another winner. So the way we're going to finish identifying this is that the y-axis is supposed to have like a radius of 3. Okay, the minor axis is vertical and it has a radius of 3. So 1, 2, 3. Oh, the x-axis is supposed to have a radius of 12. I must have messed something up in those. It's weird that it came out so perfect though. This has a 1, 2, 3. This has a radius of 4. Oh, I know what it is. No, we don't. When you multiply everything by 1/9, this should have canceled out. This should be 4 squared. Phew. Okay. Okay, so the minor axis is supposed to have a vertical radius of 3. So up 1, 2, 3. That's our winner right there. Okay, so it takes a little bit of practice. You know, maybe you wondered if you're ever going to use completing a square again. This is one of those cases where we'd need it to rewrite this expression as an ellipse.